Which of the following is the solution to the differential equation dy dx equals 2 sine x with the initial condition y of pi equals 1? So we have this differential equation dy dx equals 2 sine x. We need to solve this differential equation and plug in the initial condition that y when x equals pi is equal to 1. So when we're solving a differential equation, the first thing we want to do is move all the variables of each type to one side. So we want all the y's on one side and all the x's on the other. So we're going to treat this dy dx as a division of two differentials and multiply both sides by dx. So we'll be left with dy equals 2 sine x dx. Now we see that both sides have either y's or x's. So both sides have the same variable. So what we can do now is take the integral with respect to either y or x on both sides. Over here on the left-hand side, we have just dy, so that means the argument of our integral is going to be a 1. But since it's a 1, you don't write it, and you just assume that it's there. So now we have the integral of 1 with respect to y on the left, and the integral of 2 sine x dx with respect to x. So the integral of 1 with respect to y is just equal to y, in the same way that the integral of x dx is just x squared over 2. You take the integral of whatever's inside the integrand, in this case it's a 1, with respect to the variable in the differential. So in this case with respect to x, and in this case with respect to y. So a constant like 1 becomes y. And on the right-hand side, we'll have the integral of 2 sine x. So the 2 is a constant, so we'll just keep it. And the integral of sine x is negative cosine x, because the derivative of cosine x is negative sine x. So we'll put a negative out front to get back to sine x. And one thing we need to add is our plus c value, because these are indefinite integrals, because they don't have any bounds or limits. So both of these integrals actually had a c value. So we had like a c1 and a c2 here. But what I just did is just combine the c's. So I just subtracted the c1 from both sides and turned it into this large c term that includes c1, c2 minus c1. It's just the sum or the difference of the c values. So this one c term encompasses both of the c terms we get from the integral. And since the c terms are just constants, we can combine them into one. Okay, so this is our final form of the differential equation, meaning we've solved for y. But what we need to do now is plug in our initial condition that when x is equal to pi, so when x is equal to pi, y is equal to 1. That's what y of pi equals 1 means. So what we're going to do is plug in the value of 1 for y and a value of pi for x. So we'll have negative 2 cosine of pi. And this will allow us to solve for this c term, because we've substituted in values for x and y. So now we can solve for what value of c makes this true. So on the left-hand side, we can't do anything. It's just a 1. And on the right-hand side, the cosine of pi is equal to negative 1. And negative 1 times negative 2 is just equal to positive 2, and then plus c. So this means if we subtract 2 from both sides, c is equal to negative 1. So now we know the value of c. We can plug it back into our solved equation for y. So that means y is equal to negative 2 cosine of x minus 1. So this is our solved form for the equation y. Using the differential equation, to find this equation here, and then using our initial condition, this point on y, where when x equals pi, y equals 1, to solve for the value of c. So y equals -2 cosine x minus 1, and that's equal to answer choice E.